everyone, welcome to my channel. This is the first lesson of class 12 mathematics differential equation. In this topic we are going to cover definition, classification, order and degree of differential equation and solution to differential equation. In the coming lecture I am going to cover all the topics and all the basic things of differential equation. So after watching all the videos, I am sure you can solve any type of question on differential equation. So let's get started. At first, what is an equation is? Okay, an equation is a combinations of variables and constant having a equal to sign in middle. Okay, if something variable in left side, something variable in right side, and in between there is an equal to sign, it is called an equation. Like x is equal to 2 is an equation, x is equal to y is an equation, x plus y is equal to 2 plus 3, this is also an equation. Okay, or I can write something like x plus y is equal to y plus 2x plus 3z, this is also an equation. Okay, x is equal to 2y plus 3, this is also an equation. Okay, so what is a differential equation? In these equations there are algebraic forms x, y, 2, 3, this is also algebraic forms. Okay, if instead of algebraic form there is a derivative term in an equation, then it is called differential equation. This is an algebraic equation. So what is differential equation? If we can write a derivative term, we already know about derivative, dy by dx types terms or derivative terms. If there is a derivative term in an equation, it is called differential equation. Dy by dx plus 3 is equal to 0, this is also a differential equation. So come to a proper definition. An equation involving derivatives of dependent variable with respect to independent variable is called differential equation. Okay, if I can write dy by dx, then y is dependent variable and x is independent variable. Okay, an equation involving derivative of dependent variable with respect to independent variable, it is called a differential equation. Let's have some examples. Dy by dx plus x is equal to 1, this is a differential equation because there is a derivative term. D square y by dx square plus dy by dx plus 1 is equal to 0, this is also a differential equation because there is a derivative term and this is also a derivative term. This is the second order derivative. Okay, x dx plus y dy is equal to 0, this is also a differential equation. If you can ask where is the derivative term, so this is itself is a derivative term. We can write, if we divide dx by both sides, then we can find x plus y into dy by dx is equal to 0. Okay, so this is a derivative of dependent variable with respect to independent variable. So we can write x dx plus y dy is equal to 0. Clear? Then let's have classification. Okay, there are two type of differential equation. One is ordinary differential equation and other is partial differential equation. In ordinary differential equation, we can derivative of a dependent variable with respect to a single independent variable is called ordinary differential equation. Okay, if we have single dependent variable, it is called ordinary differential equation. And if we have more than one independent variable, if we have more than one independent variable, it is called partial differential equation. More than one independent variable, that means suppose del y by del x plus del y by del z is equal to 0. this del is denoted for partial derivative. Y is the dependent variable, x is the independent variable. Y is the dependent variable, z is the independent variable. So if we differentiate y with respect to x, and we can differentiate y with respect to z, here x and z are two independent variables. So this is a partial differential equation. Let's have some proper definition. Equation involving derivative with respect to a single independent variable. Single independent variable is called ordinary differential equation. Okay, we can write dy by dx plus 1 is equal to 0, where y is dependent variable, x is independent variable. Or we can write dy by dx plus d square y by dx square is equal to 2. This is also an example of ordinary differential equation. Now partial differential equation. Equation involving derivatives with respect to more than one independent variable. More than one independent variable. Okay, this is the important points. In case of ordinary differential equation, we have single variable, and in case of partial differential equation, you have more than one independent variable. Okay, let's have some example. Del z by del x plus del z by del y plus 1 is equal to 0, where z is dependent variable, x and y are independent variable. Single dependent variable with respect to more than one independent variable, so this is a partial differential equation. Del z by del x plus del square z by del y square is equal to 0. This is also a partial differential equation. Clear? Let's move. Now, order and degree of a differential equation. Okay, if there is an equation, we have an algebraic equation, then we have some order and some degree of, we have the degree of that algebraic equation. Like if x square plus 2x plus 3 is equal to 0, we say that this is a quadratic equation. Quadratic means order 2. In similar way, a differential equation also have a degree, and if it has a degree, since it is a differential equation, that means since it is a derivative term like dy by dx, d square y by dx square, so we have also an order of the differential equation. Order means the number of times its derivative. Okay, so this is the order of a derivative. Okay, this is the first order, this is the second order. If I can write, this is the third order. If I can write, this is the nth order, this is third order, this is nth order. So what is the order of a differential equation? The highest order derivative term in differential equation. Okay, so the highest order derivative that's involved in an equation is called higher order of the differential equation. If I can write d square y by dx square plus d cube y by dx cube plus dy by dx is equal to 0, the highest order derivative is 3. Okay, so this is order 2, this is order 3, this is order 1. Which is the highest? This is the highest. Since it is highest, so we can say 3 is the order of this differential equation. The highest order term of a differential equation is the highest order derivative. Okay, so the highest order derivative term in differential equation is called order of the differential equation. So what is degree? The highest positive integral power of the derivative that determines the order. The element or the term which determines the order, the power of that term is the degree of the differential equation. Okay, understood. The highest order derivative term is the order of total differential equation. So this is the term which define, this is the order. Okay, this is the term which define the order, right? So the power of this term is the degree. Okay, the term which determines the order, the power of that term is degree of the differential equation. So let's have some example. d square y by dx square whole power cube plus d cube y by dx cube plus 1 is equal to 0. This is the order 2, this is the order 3. Okay, so which is highest? This is highest. So this differential equation have order 3. Now come to degree. The term which determines the order, the power of that term is degree, and power of this term is 1, so degree is 1. Okay, the term which determines the order, the power of that term is the degree of the differential equation. Okay, d square y by dx square plus dy by dx is equal to 0. So this is the order 1, this is the order 2. So highest order is 2. So order of the differential equation is 2. Now come to degree. The highest power of the differential equation term which determines the order. This term determines the order. The power of this term is 2. So degree of the differential equation is 2. Okay. Now let's have some more example. If I can write d cube y by dx cube plus d square y by dx square is equal to 2. Which is the order? This is the order 3, this is the order 2. Okay. So what is the order of this differential equation? Order is 3. Since its order is 3 and this term determines the order, the power of this term is called the degree, and power of this term is 1, so degree is equal to 1. Okay, let's have one more example. D square y by dx square root is equal to d cube y by dx cube, or let's just have dy by dx. Okay, for some better understanding. Okay, so you can say this is the order 2, this is the order 1. So order of this differential equation is 2. What is the degree? This is root na, that means power 1 by 2. Can I write degree 1 power 1 by 2? No, I can't write degree power 1 by 2, because order and degree of differential equation is always integer. And which type of integer? Positive integer. Okay, order and degree of differential equation is always positive integer. So I have to solve this equation like d square y by dx square, omit this square root and taking square in both sides, is equal to dy by dx whole square. Now order is 2 and degree is 1. The term which determines the order, the power of that term is degree. Now this is integral power, so I can write degree is 1. Okay, you always remember order and degree of a differential equation is always positive integer. Can't be a fraction, can't be a negative term. Okay, it's always positive integer. Clear? Let's move. Now solution of a differential equation. Okay, what is the solution of an algebraic equation? If I can write x square minus 4 is equal to 0, then I says x is equal to 2 or x is equal to minus 2 is the solution. What does it means? It means 2 and minus 2 satisfies this equation. If I put 2 in this equation or minus 2 in this equation, then I get 0 in right hand side. Okay, this is the solution because this satisfies this equation. Same as, what is the solution of a differential equation? The function. Here algebraic term, so we get a constant term, but in differential equation we get a function, because dy by dx term is involved and y is a function. Okay, so the function which satisfies the differential equation is called the solution. Okay, there are two type of solution. One is general solution, one is particular solution. In short, if I can write, suppose dy by dx is equal to 2. Suppose this is an equation. Is this an equation or not? Yes, this is an equation because this is a derivative term. An equation having derivative term is called differential equation. Okay. Now let y is equal to 2x. I say y is equal to 2x. Then find the LHS side. LHS side is dy by dx, which is equal to d2x by dx, which is equal to 2, which is equal to RHS side. So y is equal to 2x is the solution of this differential equation. Clear? In this term, I can also write f of xy is equal to 0, means there x and y which satisfies that equation is called a solution. Two type of solution is general solution and one is particular solution. What is a general solution? Solution involving arbitrary constant is called general solution. Okay, if I write, now I have to solve this equation in general term. So I can integrate both sides. In left side integration I get y, in right side integration 2x plus c. This is the constant or integrating constant. This also called integrating constant or not. This also satisfies this equation. When I put y is equal to 2x plus 3, derivative of 2x is 2 and derivative of c is 0. So एक arbitrary constant is involved na? So this is called an general solution. Okay, when an arbitrary constant c1, c2, c3 all are integrating constant or arbitrary constant, this involves in an equation, it is called general solution. If I have a particular value for this arbitrary constant, then I can say this is a particular solution. Okay, if this arbitrary constant assign a value, then we call this is a particular solution. Okay, suppose I can give in this question as a initial condition. Suppose I can give an initial condition y of 0 is equal to 0. After finding the equation y is equal to 2x plus c, I can put y of 0 is equal to 0, which implies that in place of x is 0, in place of y is 0. So 0 is equal to 2 into 0 plus c implies that c is equal to 0. I got the solution, c is equal to 0. Now I have assigned this number arbitrary constant as 0. So now my solution is y is equal to 2x. In place of c I put 0. So this is particular solution. Okay. General solution which involves the arbitrary constant. Particular solution does not involve the arbitrary constant. We assign a value to arbitrary constant. Clear? Let's practice some question. Find order and degree of equation. This is the order 1. Okay, I don't have any other derivative terms, so I can write order is 1, and the term which determine order, the power of that term is called degree. So degree is 3. Clear? Now I can only find the order and degree of a differential equation if it is free from radical. Okay, remember I can find order and degree if it is free from radical term. Okay, so what is in radical term? That means tan inverse, ln, sin, this type of term is called radical term. So I can find as this is, if I take this ln in right hand side, then I can find d square y by dx square is equal to e power y. Okay, ln in right hand side will be e power y. So this is a differential equation and this is the order 2 and degree 1. Clear? Now this is also a radical term, so I can find dy by dx root is equal to tan of x. Inverse function in right hand side is tan x. Now order is 1. Order is 1. We have to find degree. But is this degree half? I already told you we can't write half as a degree. Why? Because a derivative, a order and degree are always a positive integer. So I have to take square in both sides. Then I get dy by dx is equal to 10 square x. Now I can say that this is the derivative of order 1 and degree 1. So I can get degree 1. Okay. So in question number C, order is 1 and degree is 1. Clear? Now this is the order of 1, this is order 3. This is a differential equation of order 3. The highest order derivative term is order. So order is 3. Okay. Now this is the power 4, but this is the power 1. And we know that the term which determine order, the power of that term is called degree. So degree is 1. Okay. Understood? In coming lecture, I am going to solve the exercise questions of differential equation. Okay. So thanks for watching.